Okay, so today's lesson is all about the volume of a prism and the volume of a cylinder. So let's just make sure we all remember what volume is. That volume is the space that is inside of a solid. If you were to picture that you had cubes that were 1 unit in volume, it would be how many of those 1 unit cubes would fit inside the solid. And so the volume of a prism and a volume of a cylinder, they are going to be the same formula. You're going to do the volume is the area of the base times the height. Okay, now it's really important that you can identify what the height is. The height is always that distance from base to base. So in this drawing of a cylinder here, here's one base, here's the other base, and the distance from base to base, or that lateral edge, is what's considered the height. And that's true even if your drawing is not like drawn where your height is actually vertical. Maybe it's horizontal. So for example, let's say that I draw this triangular prism, right? I have two bases. They are connected like this, right? If I were to highlight those two bases, it would be this is one base, this is another base, and the height is the distance between them. So notice that height is not vertical. It's the perpendicular distance between the two bases. It's that lateral edge right there. Okay, so let's take a look at a couple of examples. So it asks us to find the volume of the right triangular prism that has a height of 15. So when I think about the height, I am labeling that distance that goes between the two bases. That's our height, which is 15 centimeters. So in order to find this volume, I need to find the area of the base, and I need to find the height. Now the height they gave us, so we already know that height, which is 15. Okay, so if I were to find the area of the base, I have to identify what shape am I finding the area of? Is it that triangle or that rectangle? What shape is it that we're looking for the area of? And that base is a triangle. It's a right triangle we see here. Now, one thing I've seen a lot of us doing is still always assuming that the when you're finding the area of a triangle is finding the base and the height, always saying that the base has to be like at the bottom. But all that's true when we say that the area of a triangle is equal to base times height of the triangle, all that matters is that the base and the height are perpendicular to each other. So the base of this triangle, we may as well use this side, and the height of this triangle should be this side because they're perpendicular to each other. Now, I do need to find that height of the triangle because they didn't give it to us, but I notice I have a triple here. So that's 6, 8, 10. Okay? So when I find the area of that triangle, my base can be 8 and my height can be 6 because they are two sides of the triangle that are perpendicular to each other. Okay? So that tells me that my area of my triangle is 48, and then don't forget the area of a triangle is base times height over 2. I almost forgot that, right? Base times height over 2. Okay, so that tells me my area of the triangle is going to be 24. So my volume is going to be 24 times 15, which gives me 360. Now with volume, we have 3 dimensions, so we have centimeters cubed. Okay, now just be careful. Notice that we are talking about the base of the prism, right? And the height of the prism compared to compared to on this formula down here, the base and height of the triangle. So make sure that you're always being very careful because we use a lot of the same words, but they're not always talking about the same thing. All right, so let's take a look here. We want to find the exact volume of the cylinder. So again, our volume is going to be the area of the base. What shape that's going to be? Well, the base in this cylinder, in any cylinder, the base is a circle. So we're really talking about the area of the circle times the height of the cylinder. And remember that the height of the cylinder is always going to be the distance from base to base. So let's go ahead and start calculating some of these things. It says that the diameter is 8. So I'm going to label this distance as 8. And I'm also going to label the radius as 4. Okay, so the area of the base is going to be the area of the circle. And the area of a circle is pi r squared. So pi times that radius of 4 squared, which gives us 16 pi for the area of our circle. We want to leave it like that because it asked us for the exact volume. Okay, and then we need to figure out the height. Now, what sometimes we have to do in these volume problems is we really have to look for right triangles in our drawings. We know that height of a cylinder or a prism always has to be perpendicular to the base. So I can draw in this right triangle right here and know that we have truly a right triangle here. So if I have a right triangle where the hypotenuse is 10, one of the legs is 8, again, I have that 3, 4, 5 right triangle. So I know that my height has to be 6. Okay, so I have that 3, 4, 5. So now I can find my volume is going to be 16 pi times the height, which is 6. And so my volume is going to be 96 pi, and I have to remember my unit, meters cubed. Okay, so let's take a look at this volume question. It asks us to come up with the volume of a cube. So it asks us for this volume of a cube. We have not talked directly about this word cube, but I know you've seen it before. This is a rectangular prism, but it's more specific than that because cube means that all the sides are squares. So we actually have a square prism is what we're talking about. What that means is when you're trying to decide which two sides are faces, it doesn't really matter as long as you choose two sides that are parallel to each other. So I could choose this side as a base and this side as a base because they're parallel to each other. Because all the sides are the same square, it doesn't really matter which set I choose, but I'm going to visualize those two. Okay, and it also says the diagonal of one face is 20 root 2. Okay, so we did a lot of problems like this finding the area of a square. In order to find the area of a square, I need to find the sides. So I'm going to call this x and I'm going to call this x because they're both the same, right? And there's a couple ways that we've done this in class. We've talked about this as a 45, 45, 90 because it's a square. So we get that 45, 45, 90 triangle. That's one option. Some of you like to do Pythagorean theorem with x squared plus x squared equals 20 root 2 squared. And then some people like to use the formula for the area of a square. We know that the area of a square is equal to side squared. And so if we do that, we could solve it this way. Now, I'm not really liking the look of this method, so let's do our 45, 45, 90. I think that algebraically that one's going to be a little bit easier. So if we do our 45, 45, 90, I'm going to set up my proportions. A 45, 45, 90 has 1, 1, root 2 as its ratios for the sides. And this one we have x, x, 20 root 2. So if I set up that equation, 1 over x equals root 2 over 20 root 2. Then I can cross multiply. And I can solve for my x by dividing by root 2. And so I get x must be 20. Okay. All right, so if I get x equals 20, then I know that all my sides are 20. So if I'm going to find the volume of this cube, I'm going to do the area of the base again times the height. Well, the area of the base is the area of the square. And so the area of the square is going to be 20 times 20. And so that is 400. Okay. And this is the area of the base times the height. And then the height, the distance between the bases, right, or the lateral edge, is also 20. So we get 8,000 as our volume of a cube. And my units is centimeters cubed. All right, let's look at an example of a trapezoidal prism. So the first thing I want to do is highlight my trapezoid. So I always like to do that because I think it just helps us keep in mind what the base is that we're trying to find the area of. And then I like to highlight my height. So my height is that distance between the bases there, that lateral edge right there. So my volume is going to be the area of the trapezoid, which is the base, times the height. Okay, and so taking a look at this, the area of a trapezoid, we know the formula is base 1 plus base 2 times the height over 2. Is this height the same as the height in the volume? Are these two heights the same? They both use the word height, but they're not the same, right? This height and area of a trapezoid is talking about the perpendicular height of the trapezoid. So that is drawn in for us right here. Yeah, we have that right there. So our height of our trapezoid is 8. We know one of our bases is a distance of 4. The problem is the other base we need to know is this one, and it's not labeled for us. However, if this is a trapezoidal prism, then the bases have to be congruent to each other. So this distance of 25 has to be the same as this distance that's not labeled here. So I get my other base from the other side. It's labeled right there. So base 1 plus base 2 over times height divided by 2. And that's going to give me my area of a trapezoid. And so when I do that, I get my area of a trapezoid to be, let's see, 29 times 8 divided by 2, which I get when I do that, 29 times 8 divided by 2, so I get 116. So my volume formula is going to be 116 times the height. Now, is height going to be 8 because our other height was 8? We have to remember, in a volume formula, the height is always talking about the distance between the two bases. So my height is that lateral edge of 20. And if I multiply those, that tells me my volume is 2,320 meters cubed. Okay, now, this is a preview of a question I'm going to ask you to do tomorrow. So I want you to think about what shape is the base, if you're going to find the volume of this hexagonal prism. The area of the base is going to be the area of what shape? Well, it's going to have to be this hexagon, right? That's where we have the two parallel and congruent faces, right? So these hexagons, that's what we're talking about when we're talking about the area of the base. And then the height, it tells us actually, right? It tells us the height, the lateral edge is going to be 17. So the key to this problem is going back and remembering how to find the area of a hexagon. And I'm going to have you give that a try. You have perimeter times apothem over 2. Okay, so that's just a little hint on something you're going to see tomorrow. All right, have a great day.